experience working on my platform for the last 3 years. But first, it's my first time in the USA, and I'm very proud to be here. It's fantastic so far. You have, yes?
Oh, wait.
What?
Where are you from?
From Norway. Yeah, I'm working for Opera Software in Norway, in Oslo. I'm Italian actually, so it's a bit of a mixture. So, my Opera is the Opera Software social network community website. It started not in 1999, but in 2001 in the current form. In 1999, it was just this page, quite bad, but yeah, it started like that. Then in 2001, it became something more organized, sort of the first form of support forums for the Opera browser, where users could ask questions and receive answers. And then on to 2004, with the graphic redesigns and more functionalities, like blogs, for example, photo albums, and a lot more features. Then recently, social network integration, like Twitter, Facebook, the usual one. So in this graph, you can see the growth in users. So currently, in 2010, we have 5.5 million users, just my Opera users. And the other graph, the blue line, is the number of servers. So you can see that currently we have around 25-30 servers if we keep adding and removing, so it's unstable, it's an unstable number. But the community is growing quickly, not a massive growth, of course. This is a small site compared to what you guys are used to. But still, I think it's interesting to go through the experience we had in the scalability problem. This is the current beta version of the site, which is going to be rolled out soon. And I want to start with the situation in 2007. As the picture explains, it was a bit of a spaghetti code. So the code base was really horrible, but it wasn't the worst part of the system. The system was crashing nearly every day when I joined in 2000, it was November 2007. And the backends were collapsing, the databases were collapsing, too many connections on MySQL was a really, really usual problem. At the time we had 1,500 usually connections max, but then we raised it to 2,000 because you had too many connections, so you had to raise it, make the site cope with the connections. And then 3,000, but that wasn't just working. Then we had a central NFS volume where we store files, user uploads, and that volume was connected to all the backends and frontends. So whenever there was an outage in that NFS volume, all the site was down. So it was a giant single point of failure. Last but not least, also the team had problems because the key people that worked on the site for the last 2-3 years had left. So the team was being rebuilt almost from scratch with very young people and really enthusiastic and unexperienced. So that's when I joined. The situation was really, really bad. So everyone was really frustrated. The site, as I said, was down every day. Marketing and PR people were always looking down at developers because, I mean, why this site is down? Why can't you understand we felt the best way forward was to build our own monitoring tools. Of course, we were using already the usual tools like Munich and Nagios or Nagios, but that wasn't really enough. What was missing from the picture was a tool to get an instant overview of what was happening on the site. And we didn't have it because most of the outages were lasting like 2 minutes, 3 minutes, where the site was completely unavailable and unresponsive, and then suddenly everything worked again. So there was not even the time to look at the problem that was wrong. So we needed something more tailored to our needs, and we built it. It's a bit quick and dirty, but it's been running for 2 years, and it's been very, very useful, in my opinion. And I'll try to show you. You should never do that during a presentation, but I'll try to show you the live one. We called it the main dashboard, my Opera dashboard. This is showing the main parameters of the site. I'm not sure if you can see it, or I'll try to make it a bit not smaller. And okay. Yeah. So you can keep all the main parameters of the site under your eyes here. There's a main overview. So database connections, replication lag, and this is an average across all the machines. So average backend load, requests per second. You can see, for example, here the requests per second is like 260, so it's very low. We used to have 1,000 requests per second, but then, since this is the current situation, we try to push as much as possible to cache servers, to static files. So it's actually a very good thing if you have a low number of, this is dynamic requests per second. And then we have the detailed situation. This is by server, so we keep 3 main parameters monitored. So yeah, you can see everything: front ends, cache servers, varnish, database, master, database, slaves. And for every server, depending on the role, there's the load, disk space, and other relevant parameters. Then we have a real-time log analyzer. This fetches the access logs from the front-end servers and gives us the situation. So we use it, for example, to get the most requested URLs. I hope you can see. So yeah, the most requested URLs are the top returners. So if there's some site that suddenly links to us, we can know that instantly. If the site is unresponsive, we just fire up this one and find out. Or you can also filter by ID or user agent. And then something that proved to be a bit useful for us is also a world map situation. Because sometimes we had these cases where, especially Eastern countries, where like hammering us with requests from maybe a single proxy or cases like that. So with this one, we can immediately know, for example, that the United States are hammering on Opera, so we can just block the entire United States if we want. Of course not, but yeah, we can also filter by user agent. So, for example, our Opera Mini product is only making requests from Norway, from the US, or from Poland, because that's where the data centers are. So I mean, it's a useful tool that you can use to troubleshoot. This is not open source, but I'm trying to convince the company to do it. It's not really a big deal, but I think it's useful, and it's mostly reusable for other sites as well. So with this tool, this was the fallback slides in case there will be before. With this tool, we managed to find the most important problems that were on the site and try to fix them. And there's really many things that we had to fix. I don't want to go into the details, but feel free to ask me afterwards if you want, or even catch me around. I'll be around, so I'll be happy to discuss that future. But the most important things, fix our file-based cache that was really, really bad, and we were caching stuff by user. So we had millions of different files by user that were almost never reused. But this is essentially bad use of caching, just without thinking. You, okay, let's cache this, or let's put it in memcache, because memcache is a magic tool. It's supposed to solve everything. But you actually have to think about the structure of the data cache. So we had to restructure that. And at one point, there was a particular cache folder, which was 280 megs, but not the entire folder, just the inode of that folder. So many files it contained. So it took the poor machine 2 days to remove that folder. Then we implemented mechanisms to limit the dog file effect. So when lots of clients want to access cache content that doesn't exist, and I guess it's the classic problems that everyone dealing with scaling has to deal with. Then, persistent database and cache connections. Soft counters was not quite interesting thing. We had a counters table that was very hot, was very used, but being my ISAM table was very heavy and it locked every time we wanted to update it. So instead of using the table, we made this additional system that stores the counters in memcache, and then every now and then, like every 5 minutes, syncs the counter value in the database. And it proved to be very useful and efficient. Then, of course, lots of profiling. This is an example, just writing out long lines like this with variables and values. We were able to process them and find out the most the heaviest modules. So the ones that take up the most time during backend processing. So we picked immediately the modules where we needed to work the most. Other improvements, really, really effective, following the Y-slow plugin. So if you just follow the Y-slow analysis, you will, or we did, we lowered the response time to the client of 1 to 2 seconds, just following the basic rules of Y-slow. That was very, very, actually I think it was the best thing you can do client side. So the perception of the speed of your site, it's only improved when you do that and not all the backend activities. So do that first. And that also includes, of course, the expires pattern. That also lowered a lot the number of requests per second. And then a lot of activity on the database, like converting database tables to InnoDB, the most hot tables, the ones that were frequently used. We migrated to master setup from a master slave. We had one master and 5, 6 slaves dedicated to different activities like search or heavy queries. We migrated to same setup but master. So whenever your master goes down or there's maintenance to be done, you can just do it. And this is something I have on my wall with all the database schema. And we also, every week, we pick a random table in the database and try to find out whether that table was used or maybe it was dead, was not used anymore. And the ones marked with a red marker is actually tables that were not used anymore. So we did a lot of cleanup. And then we used Jet Provider. I think Jet Provider for MySQL is a really, really nice tool. It's commercial, it's not open source, but the license costs really, few dollars. And it was really useful to understand this is a drill down of the database state, MySQL state, so you can see the blue area is the fraction of the time your database spends while being completely locked, doing nothing, waiting for logs to be released. And this is the situation after we migrated to EDP. Before that, we had 90 to 95 of database time spent just waiting for logs. So it's really, really important. Okay, let's go to the three, I think most, or some of the most significant changes, scalability related, that we went through. First one is dealing with avatars, the really nice pictures that everyone loves. We had, in 2007, we had 70 up to 75% of the total requests to MyOpera.com consisting just of avatars. So a single page could also load 50 or even more of these. And of course, the original developers thought it was really cool to have a scale parameter, so you can scale up your avatar to 8,000 pixels by 8,000. So, and this was really killing the backend. And to add even more fun, the avatars were stored inside my absent table. So the binary data was stored inside this table. So the backends every time had to pull this data out of MySQL and just push it on the wire. So they were spending, as I said, 75% of the total time of the site on this graph. So first we were connecting to the master. Yay! Fantastic, just to read it. Then selecting the binary block data and then just pushing it out of the network. Fantastic. Avatars reloaded. Here we took all the data out of the database to a balanced file system structure, organized with just MD5 hashes split up in folders, so to balance the whole file system structure. Then made sure that we were doing any SQL queries. Of course, you build the URL to these avatars. We built a really useful component, also used now, we reused it for lots of things, that allow us to manage user upload automatically. So we can upload user files to a single server or a pool of servers, or even, in this case, pools means a set of servers that have the same content. So each file is uploaded to every different server in the pool. So this can guarantee that you can serve files with as many static servers as you need. So this was a really, really interesting component that is still part of the MyOpera. Actually, it's a really important part. We used the web tab to push the files, and of course, plain HTTP to can just add new static servers now without worrying about any problems. Just add a new server when you need more space, more server power. This is an example of the URLs and yes. So, of course, advantage is the load went down dramatically. It's a much more flexible system than not just putting your avatars in the database and being served statically. They scale, of course. The failures in this whole process were mainly two. The first one is that we based this storage component on the HTTP library, which is a CMAN module that had a really bad flaw, but we discovered that 3 days before putting everything in production. And we were able to fix it and to actually take maintenance of that module. So now Opera maintains it, and it's a critical part of that infrastructure. That doesn't mean that we have to continue to use DAO if we want to migrate to S3 maybe. Yeah, we could do that if the system allows that. That at this time was really critical. Another really big failure, actually we didn't avoid this when we went to production. The site was running fantastically and smoothly for the first few minutes, and then everything went down because the problem was that we wanted to pre-compute all the URLs of the avatars, so the ones you saw here, the caches stuff. To calculate that, we needed the user ID, but we had the user name. So on a page with the 500 avatars, maybe they are not even displayed because our system is just weird. That don't matter. But yeah, let's say with the 500 avatars, we needed to pre-compute all the URLs before displaying the page. That was hitting the database 500 times. So it brought the entire site down. Instead, now we just use this form, the stupid username / avatar here, which allows us to not pre-compute the URL, so it's a big thing. The second most significant scalability change is varnish. I'm not sure if some of you were attending the talk by Arthur yesterday. He talked about varnish. It's really fantastic. But how many of you use or know about varnish? Yeah, okay. How many of you use varnish in production? Well, okay. For the others that don't know it or don't use it, well, try to take some time to actually go into it because it's fantastic. Varnish is the extreme logging chainsaw as opposed to plastic saw for babies. So pay attention when you start using it because you can hurt yourself, but it's really effective. With varnish, we did a lot of things, and we tried to learn by using it. So the first use of varnish was very simple. Then we went on while we were learning. So these are the four things I will explain today. First usage was just to cache RSS feeds. These are very popular on my Opera, so we just and they don't change by user, so it's basically just a static file. So we started caching RSS feeds, APIs, simple APIs. And the only thing you need to do that is to strip the cookies. So varnish, which is reverse proxy, if you happen to not know, and if you have questions, please stop me and ask. So what you need to do here is just take the client request, script the cookies and send it to your backend. That will make sure that Varnish will just cache one version of the object. So this was fantastic and great. We were really happy. So we went on caching the MyOpera front page, which is an entirely different thing because you have logged in users, so you have to pay attention. You actually have to pay really much attention, and we didn't. So what happened at some point was that random people were getting other random people sessions, and maybe with admin privileges. So this was really a nightmare, and we had to work day and night to fix it. But yeah, in the end, it was fixed. But it was pretty bad nightmare. I think we were using at the time Varnish 1 because it's the version that comes with the Debian 5. But please don't use it. Be sure to use 2.0 or more recent. To effectively cache the HTML pages, any HTML pages, you have to be prepared to process your cookies in a very interesting way. For example, if you use Google Analytics has all the UT tracker cookies. You have to strip those because otherwise, by default, Varnish will cache pages depending on the cookies too. So you will end up with millions of different versions of the front page, which you don't want. Same thing goes for the accept language header. So if the browser is configured to serve pages in English or Italian or French or whatever, the MyOpera front page adapts automatically. So you have to normalize the accept language header, because otherwise we'll end up again with thousands of versions of the page. Actually, there's a small project of mine here. It's an extension to Varnish just to do that, the accept language headers normalization. It's a bit of C code that you can embed into Varnish to do that. It's very interesting and it's been running in production and very well. The third use of Varnish was for the Opera Mini 5 approval. Any questions so far? So when Opera decided to submit Opera Mini to the Apple Store, there was a big PR campaign and there was a special MyOpera page that was prepared for this, where people were supposed to go there and check this timer or guess when Opera Mini would have been approved by Apple. So this link went on to all the major websites, which for us it's not very frequent, so we were a bit excited. We're used all over the internet. So we were a bit worried that this could really crash the site. Marketing told us, yeah, it needs to be out tomorrow, and it will be really huge. There will be a huge press release, but unfortunately, everything went better than expected. No problems whatsoever, because we just routed the request to this special page to Varnish. So, yeah, we got like 2,000 requests per second without any problem. That was great. This was between March and April this year. Last one, Datacenter emergencies. You should never have Datacenter emergencies, of course, because you're planning everything perfectly, but we don't. So we had an emergency, and the emergency was that all the bandwidth on our main data center, or actually not all the bandwidth, but we were reaching separation of bandwidth want for my Opera, I assure you we don't saturate gigabit networks with my Opera. It was with mainly with OpenVPN traffic, but we live in the same data center, so we have to cope with this problem. The traffic for 5 nanoperform was really high, so we had to find a way to route this traffic elsewhere. We had another data center. So we used varnish also in this case. The new data center, we set up 2 varnish servers that we had the load balancer that were connected to the original storage volume for 5 nanoperform. We made varnish act as a reverse proxy connected to the other data center where the real data was. In this way, we were able to save lots of bandwidth and to just route it to a different data center with the DNS. In this case, just to give you a quick figure, we had many thousands of requests per second on 5 nanoperform on the varnish servers, but on the backend, we had like 30 connections going on. So what varnish does is, in this case, we had a really good integration, so it completely reduces the traffic to the backend. So that was a really good thing for us. And to understand a bit better how varnish performs, this is a Lunin chart. You can see this is the network traffic. You can see that varnish is actually saturating the network card. So this is pushing 980 megabits per second. This is a single varnish instance. It's pretty impressive. So again, varnish, yes, decreased the load to the backend quite a lot, and it's, as you saw, flexible, you can move around and stuff. Provides instant scaling, so just add another one and you are good to go. It's a chainsaw, so please pay attention to what you do. We spent, I think, at least 3 months just getting familiar with the product. The VCL config system is very powerful, very flexible, so you have to get into it. And then you have to pay attention to purging, because we were very excited, varnish is working great, so yeah, let's catch this, catch that, but then you have to deal with purging, and it's not really straightforward how to do that. Purging in varnish, you have to provide special config, and yeah. Now with varnish 3, we will still use 2.0, but there's with varnish 3 they changed the way you can manage purging, and it's called bands. It's slightly different, so I have to study a bit how to do it. Third and last one is GeoDNS, which is a simple, very simple project that we built in-house. It's very quick and dirty, but I think for what we need, it's really, really working great. Basically, this is about using DNS to divert traffic to different data centers. And we have invented it. Of course, we didn't invent it. Everyone is doing the same. But in this case, the sort of special thing is that it's just really, really simple. We use the Power DNS as a DNS product, and Power DNS as an open backend feature, which is simply something to say you can write your own backend in any language you want. Power DNS will call your program, pass the DNS queries over standard input, and get the responses over standard output. So your program is just talking standard in, standard out, and it can provide DNS requests. just hooked up the PowerDM's backend to the OIP, the MaxMind library. So whenever a client comes from China, we just direct him to the Chinese data center that Opera is there. Whenever a client comes from the US, we direct him to the US data center. Nothing more than that, then it works great. First prototype for this project was done in 1 week, so it's really, really simple. It provides a sort of geographic scaling, maybe urban geographic scaling, but for us it works fine now. It's also very simply redundant, because you can just add new DNS servers in new data centers, and you're fine with DNS itself. You can direct clients to many different DNS servers. The drawbacks of this system is that it's not really accurate 100%, because the MaxMind libraries are not really accurate. At the moment, there's no data center feedback in the loop, so if ever a data center goes down, you don't know about that. So you direct clients to that data center, but it's down. So we plan to build some sort of data center feedback. And monitoring, we do monitoring, but it's not really, could be a bit better. So we have to build up a bit more. Especially, we don't really know now where the clients are being directed, like percentages, for example, of usage of data center. Okay. Next steps for my overdesk. There's so many things to be fixed. I don't know really, but I think some of the important steps will be adding a search here, and probably we will use Solar for this because there's some expertise already in-house. Then we'll have to fetch the activity feed part of my overdesk. Currently is built on the file database queries, so that tells you we don't have a massive traffic. Then, other things like real connection pooling, and so on and so forth. But I want to leave you with just a few simple things. I think team spirit is the most important thing. If you have really dedicated people that are really interested in what you're doing, even if you have, scaling problems, okay? If there's people that want to go deep into the problems and find solutions, even if they are not really experienced, I think that's the people you're looking for. That's the people that will build your solution. So if you put team spirit into that, you get a fantastic situation to go scale your site to many levels. Then, another level of interaction can solve any computer engineering problem. Of course, varnish is just a reverse proxy, so you're just putting something in front of your current infrastructure. Memcache is the same in some way with the database. So, scaling is not really that complicated. And then there's people that already did that for us. I just learned everything I know from other people's blogs, and it's not really keep it simple, and please keep a log of your failures or outages. This So the question is, if we have seen some situations, some case where varnish will truncate the cookies while you're doing all the mapping and so on. No, but there's a related problem, that is the session size. By default, varnish has HTTP, it's called HTTP, I think, no, sorry, session workspace, it's called. By default, it's something like 16K. That's the amount of space that varnish uses to process your cookies. So to create new strings and set new headers. So if you exceed that space, that's not the case. Okay. But yeah, that could be the only thing I can think of. That's usually we set the session workspace at least to 64 or 128. But yeah, if you have dogs, yeah, great. I'll take a look at it. Any other question? Come on! Yes.
For your full dashboard where you're tracking the IP risk, are you grabbing it from logs or are you databasing that?
Yeah, as I said, the question is the Mallorca dashboard, whether we are fetching that from the logs or from the database. We're just grabbing the last section of the access logs for the front-end servers. So as I said, it's a really quick and dirty solution. But I think it works well. So yeah, just access logs. The last, I think 50,000 lines or something. So every time the dashboard updates, it means that it parses the last 50,000 lines of all the front-end servers. It just works. Maybe it's not fast, super fast, but yeah. Other questions? Yes?
You mentioned you're doing a master application.
Yeah.
Are you doing a lot of IDC or are you?
Sorry, master application, but?
That's like doing MySQL.
Yeah, MySQL.
How are you doing a lot of IDs? Like collisions or anything like that?
Yeah, in a very stupid way. The question is how we are dealing with auto-increment IDs with the master MySQL setup. We just configured the two primary and secondary master to have a different auto-increment offset. It's just offset by 10. So yeah, I mean, we need space to have other masters. You never know, but yeah, nothing more.